Number one, the radius of a sphere is r. The absolute uncertainty in r is delta r. What is the fractional uncertainty in the volume of the sphere? The volume, the volume of a sphere is volume equal 4/3 pi r cubed. For a quantity like this volume, which depends on r cubed, the result of volume depends on the values of r cubed. We use the formula, the next formula for the propagations of uncertainty, and we need to find the delta V. Delta V is the differential. It is 3 times 4, 3 times 4 third is 4 pi r squared and delta r. Okay, because this is delta V dV dr, this one. Okay, so if delta V over V, if we can find the fractional uncertainty, it is 4 pi r squared over 4 third pi r cubed. This is delta r. And it's going to be 3, 1, r squared is delta r over r. So the solution is this one, A. Which quantity has the fundamental SI units of kg s to the power minus 3 or kg over 7 kg over second cube? If power the unit is kg meter squared second power minus 3. Intensity is one the unit kg second power minus 3. Momentum, the unit is kg meter per second. And energy, the unit is kg meter squared per second cubed. So the solution is this one, intensity. A runner accelerates from rest and reaches a constant speed time t. What is the variations of displacement with time t? Option A is not the solution because you look at point t, there is no variation displacements. The runner take a rest. B is not the option. Option B is not the solution because there's no constant. At t, the displacement no constant. C, at point t, displacement, the runner take a rest, it stop, and the solution is D because option D, you look at time t, the runner displacement is constant. A balloon rises at a steady vertical velocity of 10 meters per second. An object is released at rest relative to the balloon. When the object is at a height 120 meters above the ground, air resistance is negligible. What time? To the nearest second does the object take to hit the ground? For we will use the kinematic equation to find the time it takes for the object to hit the ground. And the equation ht equal h0 plus v0t minus 1/2 gt squared. ht, the height of the object at time At time t, h0 is the initial height 120 meters, it's 1, and v0 is initial velocity upwards 10 meters per second. G is gravitational force 9.8 meters per second squared, and T is time, the unit in second. We want to find the time T, this T when the object hits the ground. So it means if it hits the ground, HT must be 0. So substitute this information into this equation, and it's going to be 0 equal 120 plus 10t minus 1 half times 9.8 t squared. It's going to be 120 plus 10t minus 4.9 t squared equals 0. Now, we will find the value of t, so we need to, using ABC formula, identify A equal minus 4.9, B equals 10, and C equals 120. So T1 and T2 equal minus 10 plus minus square root 10 squared minus 4 times minus 4.9 times 120 divided by 2 times minus 4.9 becomes minus 10 plus minus square root 100 plus 2,352 divided by minus 9.8, and it is minus 10 plus minus square roots of this number is 49.52 divided by minus 9.8. Scroll down first. So T1 and T2 equal T1, we can determine T1 minus 10 plus 49.52 over minus 9.8, and the result is minus 4.03. But we will not using this result, this value, because time never negative. Second T minus 10 minus 49.52 over minus 9.8. The result is 6.07. Round off becomes 6 seconds. And this is the solution, 6 seconds. It means this one, C. Next question. Number 5. An object of mass 10 kg is initially at rest at the top of a slope of length 50 meters. A constant net force of 40 newtons acts on the object down the slope. So the diagram. What is the speed of the object at the bottom of the slope? Firstly, I would like to find the work done F times D. F is 40 Newton, one, and D is 50 meters. So if you calculate, the result is 2000 joule, Newton meters per joule. And the next, the change of kinetic energy. The change of kinetic energy is delta T E. The formula is 1/2 mv squared, or 1/2 times 10 kg v squared becomes 5 v squared. Energy stored in spring as energy, sorry, the energy, I mean this kinetic energy, the energy, change energy in kinetic energy, it becomes delta K E equal 1/2 mv squared. So this is 5v squared. This is 2000. So v squared equal 400. So v equals square root 420 meter per second. Solution. Yes, now I thought number six. Number six, when a horizontal spring is extended by a distance x, the force acting on the spring is F. The extension of the spring is directly proportional to the force. What is the energy stored in the spring? The energy stored in the energy stored in the spring given by this formula E equal 1/2 kx squared. And the formula of F or force is, I'm going to write it here, force is K times X. K is spring constant, X is extensions of spring. And we can rearrange this formula, becomes K equal F over X. So substitute this equation, this fraction into this formula, becomes E equal 1/2 times F over X of X squared times X squared. So it becomes E equal 1/2 F X 1/2 F X 1. This one, C. The solution is C. Number 7. An object of mass is 6 kg is accelerated horizontally from rest in 4 seconds to reach a speed 10 meters per second. What is the average power delivered to the object? So the kinetic energy, the change of kinetic energy or delta Ke plus 1/2 mv squared. Substitute this information 1/2 times 6 is 1 kg and times 10 meters per second. If you calculate this, this is squared, okay, because v squared, and this is 100 times 300 joule. Power, the formula is work done over time taken. Work done is 300 joule, while time taken is 4.0 seconds. And the result is 75 watts. 75 is 1, C. Number 8. An athlete of mass M jumps vertically upward, lifting their center of mass at distance h after losing contact with the ground. What is the impulse that acts on the athlete during contact with the ground? Impulse, we are going to discuss about impulse. Impulse is the change in momentum, and the formula of impulse is J equal delta P, change in momentum. And in this case, the initial momentum or P initial of momentum initial equal 0. We use kinematic equation to find the velocity just before the athlete leaves the ground. And the formula is the final velocity squared equal the initial velocity squared plus 2gh. Okay. Vf is the final velocity with the maximum height. The final velocity, the maximum height is 0. Okay, so it becomes 0 equal Vi squared plus 2gh. So it means Vi squared equal minus 2gh, or this is constant number. This is constant. So Vi we can set as minus square root of 2gh, right? Even there is no negative result for velocity, right? So delta V change in velocity equal Vf, the final velocity, minus the initial velocity. The final velocity is 0, and this is the initial velocity minus square root 2gh. So it becomes square root 2gh. And impulse equals mass, or m, mass times delta V, or m times square root of 2gh swan. So the solution is this. Number 9. A toy car collides with an identical toy car at rest. The cars stick together. The surface is frictionless. Three statements about these collisions are: 1. The speed of one car decreases and the speed of the other car increases. This is correct. It's one. One correct. Okay. 2. Total momentum is conserved. Yeah, correct, I think. Kinetic energy, this is not. This is incorrect. So which statement are true? 1 and 2 only. It's one. Number 10. A heater of power P provides energy to a liquid at its boiling point. A mass m of the liquid vaporizes in time t. The specific latent heat of vaporization is L. How much energy is transferred to the surroundings in times t? The energy supplied by the heater, I would like to write in E heater equal power times time. And energy required for the vaporization, I would like to write in E vaporization equal M times L. So the energy surrounding, or ES, it is P times T minus M times L. Which one? Or this one? 11. The molar mass of helium is 4.0 G per mole, or G mole power minus 1. A sample of helium or has mass 0.50 grams. How many molecules of helium are there in the sample? Number of moles of helium, we can writing as N equal mass of the sample, M, or mass of the sample, over molar mass of helium. Okay, molar mass of helium, and it is 0.50 according to this information over 4.0 G per mole. if we calculate, the result is 0.125 mole. This is G, okay, grams. This one, 0.125. Next, number of molecules based on Avogadro numbers, the Avogadro's number is 6.022 times 10 power 23 molecules more. And number of helium molecules n equal n, this n, lowercase n times n a, this one. This is Na, number of Avogadros. So 0.125 times 6.022 times 10 to the power 23. And the result is 7.5275 times 10 power 22 molecules. And the result is this one, B. Number 12, an ideal gas is in a container with a movable piston. The piston compresses the gas rapidly. The temperature of the gas increases because, okay, if the condition like this is the container and there is a cup like this, and inside the container there's a molecule inside this one. So if you press the molecule inside the container, the implication is the molecules are all molecules inside the container will be bounces and uh, it will press the cup when you pressure the cup to downward. So it means the solution is the exact solution is one. Molecules bounce off the piston with increased speed or B more speed. Next. A particle is displaced in the negative direction and released from rest at time t equals 0. It performs simple harmonic motion, which graph shows variations with time t of the velocity phi of the particle. Simple harmonic motion has two characteristics. First, it starts at t equals 0, and the second, it increase in the positive direction. So the correct option is this one, A, because it starts from 0 and has positive direction. This is incorrect because not start from 0. As well, if you evaluate C as well, not start from 0, even it has positive direction. D start from 0, but not increase. This is decrease direction. So the correct option is A. Next, number 14. A traveling wave of time period 2.0 second is moving through a medium. The graph shows for one instant the variations with distance of displacement of particles in the medium. The question, what is the speed of the wave? The speed of the wave is the speed or velocity distance over time. The distance for one period is this one. The distance is 1.5, and the time is 2.0 second. This is in meters. So it's 1.5. The result is 0.75 meter per second. The option is this one. Source X and source Y both emit waves of wavelength 0.4 meters. There is a constant phase difference of pi radian between the source. Point P is 5.2 meters from X and 4.6 meters from Y. The amplitude of each wave at P is A. The amplitude is A. What is the amplitude of the resultant wave at P? So A plus A, of course, is 1, 2A. Number 16, an electromagnetic wave travels from medium 1 to medium 2. The wavelength of the wave in medium 1 is lambda 1. The wavelength of the wave in medium 2 is lambda 2. The refractive index of medium 1 is n. It's medium 1 and it's medium 2. What is the refractive index of medium 2? I will using the relationship formula n1 times lambda 1 equal n2 lambda 2. So the implication n2, because relative index of medium 2, so n2 equal n1 lambda 1 over lambda 2. This one. This one. This is the solution. A standing wave is set up in a pipe with one closed end. One harmonic of the standing wave has a frequency 180 Hz. The next harmonic has a frequency of 300 Hz. What is the frequency of the first harmonic of the standing wave? The frequency of these harmonics are related by the formula Fn equal n times F1. The frequencies are spaced by odd multiplies of the fundamental frequencies. So it means we can writing that F3 equal 180 Hertz. So this is actually F3 times F3, and F5 or F5 is 300 Hertz, this one. So an odd number, so it means we can state that F5 actually is 5 times F1, or F3 equal 3 times F1, like this. So if F5 equal 5 times F1, it means F5 equal F5 equal F5 equal 5 F1. So it means F1 equal F5 divided by 5. And if F5 is 300 Hertz, so F1 equal 300 Hertz divided by 5, and the result is 60 Hertz. This one, B. The diagram shows electrostatic field lines. The source of the field is not shown. At which position in the field would a negative point charge experience the greatest force to the right? Uh, okay, so uh, the direction is toward to the left. That's very simple. Just fine. It's the direction to the left, and it's one D. Yeah. B no, C no, A after. So this direction to the left. A conductor has resistance of 1,000 ohm or 1 kilo ohms. The length of the conductor is 20 kilometers, and the cross-sectional area is 1 millimeter squared. What is the resistivity of this conductor? Okay. The formula I would like to using this formula that R equal rho times L over A. Or we can rearrange this formula becomes rho equal R times A over L because we are going to find rho. So rho equal, substitute this information, 1 kilo ohm is 1.0 times 10 cube because it's 1,000 times A is 1.0 times 10 or minus 6 over 20 times 10 cube. 1.0 times 1.0 is 1.0 times 3 minus 6, 10 power minus 3. 20 times 10 cube. That means 1.0 over 20 times 10 power 6, like this. So it becomes 1 over 20, 0.05 times 10 power minus 6, or is 5.0 times 10 power minus 8 ohm meter. Which one? 5 plus, oh, this one, B. So the answer is 5.0. Oh no, this one. This one. This is minus 5. A cell has an electromotive force of 17.0 volt and internal resistance R. It is connected to two 10 ohms external resistor. So this is internal resistor and this is the external resistor at that parallel. There is a current of 1.5 amps in one of the external resistor. What is the value of R? Right. So I would like to find the total resistance 1 over R total equal 1 over 10 plus 1 over 10 equal 2 over 10. So the total resistance equal 10 divided by 2 equal 5 ohms. This is the total resistance. And after that, the total current equal 1.5 times 1.5 plus 1.5, 3 amps. So it means the EMF equal, based on the formula EMF equal current times internal resistance plus total resistance equal. I will rearrange this formula becomes E over I equal R plus R. The internal resistance equal E over I minus the external resistance, and the answer. So R equal E is 17, I is 3 minus 5, and the result is 0.67 ohm. This one, 21. P and Q are two parallel wires perpendicular to the page that carry currents of equal magnitude in opposite direction. The current in P is out of the page. R is fixed point equidistant from P and Q. What is the direction of the magnetic field produced at R? So we have to using the principle of right-hand rule. Right-hand rule principle. Uh, on wire P first. On wire P, because of the principle of right-hand rule, the magnetic field direction will be uh, to the left of R, so will be to there. Okay, from wire P. Now wire Q, because based on the right-hand rule, the affect for point R, the magnetic field direction to the right. So final direction is this one, A, the implication. 22. X and Y are 2 points on a disk of radius Z rotating on a constant angular speed. X is at a distance Z half from the center of Y is at a distance C from the center. What is the linear velocity of X over linear velocity of Y? Okay, for linear velocity is I would like to what is V x equal Rx. So R is radial distance, and omega is the angular velocity equal 3 half times omega because Rx. And the linear velocity Y equal Ry omega Z times omega. So it means if the velocity, linear velocity X and linear velocity Y is equal Z half omega Z omega, and it is 1/2. So this is B. Yeah. Whether linear velocity of X over linear velocity of Y, and as well accelerations, you can using this one, this rule. Next question, number 23. The diagram shows two masses that are fixed in a position. One has a mass of m and other has a mass of 3m. The line through the masses is divided into three segments, A, X, Y, and Z. The net gravitational field can be directed to the left in, of course, C direction will be to the left, and Y as well, because 3m, this object has masses greater than m. So Z and Y direction will be to the left. And the answer is this one, C. 24. I'm going to change this one. An unstable nuclide has too many protons. What is the most likely decay of the nuclei. Okay, the 34 alpha, beta minus this one, beta plus. The four energy, number 25, the four energy states for an atom are shown. This one. What is the lowest frequency of radiations that can be absorbed by the atom? Okay. E1 minus E4, E1 minus E4, one. Oh, the smallest is one, between E4 and E3. This is the smallest. So the lowest, it means the smallest gap is one. That means the lowest between E4 and E3, this one, D. Next question, 26. Which list correctly shows three fundamental forces in increasing order of rings: weak nuclear, strong nuclear, electromagnetic. This correct? Strong nuclear? No. Strong nuclear? Oh, no. Yeah. The correct is option A. 27. The reaction, this reaction is proposed three conservation laws in particle reactions are conservation charge, conservations of baryon number, conservations of lepton number. Okay, we are going to check one by one. For conservation charge, on this is the left hand side and this is the right hand side. I will separate like that, like that. The charge of the particle, look this pi power zero. This pi power zero has charge. This is charge has charge zero, and the property of p is has charge one, positive one here. And on the right hand side, the proton, the proton has charge positive one, electron has charge minus one, and then neutrino has charge zero. The charge is zero. So the left hand side for especially for this one, for conservation of charge, left hand side, the left hand side has total charge zero plus one, and it is plus one. Right hand side, the right hand side has total charge, this one, plus one, plus minus one, okay, plus zero, and equal zero. So this is violated. Charge conservation is violated. Okay, because unequal. This is zero, this one is zero. Now this one, conservations of baryon number. If you look the left hand side and right hand side, uh, the lepton, the lepton, sorry, the baryon, I mean the baryon number, this one has baryon number zero, and the proton has baryon number one. So left hand side, zero plus one, positive one. Right hand side. The right hand side, proton has baryon number one, okay, positive one, and the electron and the neutron has baryon number. There is no baryon number here, but it means zero, 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 equal positive one. So this is, if you look the left hand side and the right hand side, it is conserved. Okay. Now this one, Conservations of lepton number. The lepton number, if you look the left-hand side and right-hand side, uh, this one pi its power 0 has lepton number on left-hand side, lepton number 0. And the proton has lepton number 0 as well, without lepton number, so it is 0, equal 0, right-hand side. Now, on right-hand side, the proton has lepton number 0, without lepton number, so it means 0. Okay. And electron, on electron, it has 1 lepton number, and neutrino has 1 lepton number also, and it is 2, so it is violated. So violated 1 and 2, which one 1 and 2, this one, A. That is number, oh, sorry, 1 and 3, I mean, not 1 and 2, but 1 and 3. This one. Next question, 28. Once research is completed, scientists gather support for the validity of their work by using common terminology, no, collaborating with others, no, improving their instrumentation, no, obtaining, oh, this one, yeah. 28. 29. Three energy sources for power stations are nuclear fuel, sunlight, fossil fuel, which energy sources are primary sources. All of these are primary sources, 1, 2, and 3. So this one, D. 30. The surface of a planet absorbs an intensity of 400 watt meter per second squared and reflects 100 meter per second squared. The surface of the planet is at equilibrium of a constant temperature. What is the albedo of the planet's surface and radiated intensity? So we need to calculate the albedo and radiated intensity. For albedo or alpha, the formula is reflected intensity 100 watt per meter squared divided by incident intensity 400 watts per meter squared, and divided, and it is 1/4 or 0.25. Next, for radiated intensity, the formula is incident intensity, so divided, incident intensity 400 watt per meter squared minus the reflected intensity 100 watt per meter squared. It is 300 watt per meter squared. This one. So the solutions is this one. C. The option is C.